This is a short video including an introduction and explanation of the combinatorial proof method. Towards the end of the video, as is a series of progressively more difficult examples. The video was constructed by a group B14, which is comprised of TJ Bierce, Matthew Berger, Zach Houston, and Ryan Kreider. This video itself is viewable on knoatom.com, that is knoatom.com. For a short overview of what exactly is a combinatorial proof method. It is established through proving the equivalence of two counting expressions exclusively with counting principles, essentially two different stories which can arrive at the same conclusion. This proof method allows us to look at an equation differently rather than exclusively rely on algebra. The structure of a combinatorial proof is done and executed in four different steps. First, define a set S. Second, show that the cardinality of that set S is equivalent to n by counting one way. Third, show that the cardinality of S is equivalent to m by counting in an alternative way. Fourth, conclude that n is equivalent to m. The first example is a simple but introductory example aimed with the goal to provide a basic understanding of what exactly it is a combinatorial proof. In this example, the goal is to prove that choose k from n is equivalent to choose n minus k from n. Consider a scenario where you have n different competitors. Of these competitors, k must win the competition. We will define set S as all winners. Route 1. We need to choose k winners from n people. Choose k from n. Second, choosing k winners is the same as choosing n minus k losers. This is because they are complements within the universe of competitors, that is, choose n minus k from n. In conclusion, for this example, we counted the same thing in two ways, therefore these expressions must be equal for equal n and k. Example 2 involves Pascal's theorem. In this, we prove that choose k from n is equivalent to choose k minus 1 from n minus 1 plus choose k from n minus 1. Consider a March Madness style scenario where k teams are in a place in a bracket out of a total n teams, the number of Division I teams in this example. S will be the set of all possible teams to play in the tournament. The first way can be counted by considering the situation in which a certain team is within the bracket and the situation in which a team is not within the bracket. In the first case, the number of teams is reduced by 1, as is the number of remaining bracket places in the tournament. This is true because once a team is in the bracket, they are also no longer in the total pool. In the second case, at the same time, once they are placed in the bracket, there is one less place to be selected in the bracket itself. This can be given as choose k minus 1 from n minus 1. In the second situation, the team is not picked as part of the bracket pool. At this point, the number of total options to be placed into the bracket is reduced by 1, and this makes it n minus 1, while the positions in the bracket itself remain the same. As such, it remains as k. Therefore, choose k from n minus 1. A summation of this route. When these two situations are combined, that is the case where the team in question makes the bracket and the case where the team does not make the bracket, the result is choose k minus 1 from n minus 1 plus choose k from n minus 1. In the second route, it is rather straightforward. In this situation, there are n teams, including the team in question, trying out for the k spots in the bracket. This can be given as choose k from n. In conclusion, because we counted the same scenario in two different ways, then these two ways must also be equal. That is, choose k from n is equivalent to choose k from n minus 1 plus choose k minus 1 from n minus 1. Example 3. Prove that the summation from I equals 0 to k for m choose I and choose k minus I from n minus m is equivalent to choose k from n. Consider a university where n students have a unique student number 0 to n. We want to choose the k students to expel. In the first route, each set of students has a largest student ID. We're calling this j. First, find the number of sets with the largest ID, j. J is in the set, so there are k minus 1 to choose from. Because j is the largest, we choose from j minus 1 elements. Now sum all the sets that have j as the largest element for all j. That is, sum from j equals 1 to k. Choose k minus 1 from j minus 1. Route 2. As before, n choose k is k choose n, or choose k from n.